Hello friends, today we will discuss set. What is the set is? First we write the definition of the set. A set is a well-defined object. A set is a collection of well-defined collection of objects. Right? A set is a well-defined collection of objects. Right? And that do not change from person to person. It's not that is my collection is different, is my thinking is different, the other's thinking is different. It must be neutral for all. It must be universal for all. That is the like in mathematics, the set of natural numbers. Right? Since we are the mathematics students, so we know what is a set of natural numbers, set of integers. Right? These are universals. Right? The set of reals. Right? So this definition, this collection do not change from person to person. Right? While what are non-sets? Example non-sets. Is the collection of collection of objects change from person to person. Change from person to person. Change from person to person. Example, like we can see this collection of freeze paper. Right? So each person may have the different thinking of the richness. Somebody says who is rich according to property. Somebody says who is rich according to the money, cash. Somebody says he's a rich because of his donation power, right? Because of his charity power. So that definition changes from person to person. It's not the same. Means my thinking may be different, others' thinking may be different. So that depends on the that is not a set. Whereas according mathematically, it's not a set, right? So similarly, we can take the collection of best movies. We don't write the seems that it is no. There's a collection of rich people, so that's a change from person to person. Collection of best movies. This change from person to person. Somebody likes English movies, somebody likes Hindi movies, somebody likes Russian movies. So that changes from person to person, right? So mathematically, this is not a set. Okay. Now these are the set. Now set can be written. A set can be expressed in three forms. Expression of sets. Expressions of sets. It can be expressed in three forms, right? One is the roster form. Another is a statement form, right? Another is a set builder form. Right? In this set roster form, the elements of the all elements of a set are listed. Are listed. Right? Right? The set of natural number. The set of natural, for example, the set of natural number. So here we can write this natural number begins with 1, 2, 3, 4. So we can write this n as 1, 2, 3, 4, and so on. Right? And another is this set of reals. Set of reals or a set of real numbers. So that is, it is this. It's you know that in between reals we have so many numbers. So sometimes it becomes very difficult. So we can write this as -4, right? -3, then -2, -1, then 0, then 1, then 2. It's something like this, right? And what is set of naturals? So for that we need a set builder form. Instead of writing this set of reals, we need a set builder form, right? And similarly, the set of students, set of 5 students. So because I'm naming 5 students, so I'm writing that set of 5 students. So this is, I can name those students, right? So that is S representing for students. It is, I can write, it's Ram, it's John, right? It's Meena, Sheena, and another is one more name is required. So this is basically the roster form. Color. Right? This is basically roster form. Now what is statement form? Statement form is definitely a set is expressed in a statement. Expressed in statement. Examples, that is the set of natural numbers. Sometimes we write statement in curly bracket too. A set of reals. And note, sometimes the statement form is written in the curly bracket too. Bracket. That is natural numbers less than natural numbers. Natural numbers less than 5. Numbers less than 5. That is a statement form, right? Another is, that's a modern definition, a modern form of writing set. Another is a set builder form. This, the set is expressed, the elements of the sets, elements or the objects. Are expressed with the defined property. Right? With the defined X, that is with the defined property. Okay, like we may write the set of natural numbers. Of natural numbers. This is statement form. The set of natural numbers is, we denote the natural numbers by n. So that means we can write this n is, or the set is x such that x belonging to n. This is set builder form, right? If we can write this, even if you think that the ma'am, this is a problem that we can't read, this is n, this is n, the same n. So what's the use of that? We can write another way. That A, then this is a set of natural numbers. A is a set of natural numbers, right? X is an x belonging to n. Similarly, if we want to say that this x is less than 5, so that means another form, if it is natural number less than 5, set of natural numbers less than 5. Set of natural numbers. This is one example. This is another example of natural numbers less than 5. So for that, I can write this as B is the set that contains a natural number and the natural numbers are less than 5. In the roster form, I can write just 1, 2, 3, 4, right? But in the statement form, this is set of natural number less than 5. And in the set builder form, it is x belonging to n such that x is less than 5. That is the way. And one thing that should be notable, or this is that the sets are represented by the capital letter. represented by the capital letter. Right? By the capital letter. Right? Elements of the sets are represented by small letter. Why? What happened? Elements are represented by small letters. Okay. So usually n is the symbol for the set of natural numbers. Natural numbers are represented. Set of natural numbers. Z is the symbol for set of integers or integer numbers. R is the set of reals or the real numbers. Q is the set of rationals. Q is a set of rationals. Right? Sometimes we take double instead of this and this Z, right? And similarly for the Q, we write this. Q is it's a this is a Greek style of writing. It's Q. Okay, so Q, and then I is they are saying I is represented by the rationals, irrationals, but sometimes we use I for the integers too. Set of irrationals. But now they are changed. So many notations are changed. Set of irrationals or set of irrational numbers. Right? Now sets are of two types. Finite set and infinite set. Finite set and infinite set. And infinite set. Right? Types of sets. Finite set is a set which contains finite number of elements. Finite elements or finite number of elements. Is called finite set. Infinite set. Infinite set is a set whose numbers can't be counted, right? So how to write that this number is not counted or is a set that has infinite number of elements. So infinite set, a set that has infinite number of elements or a set whose elements are not counted. Means we can count, sorry, we can count the set, we can count the elements in counted as is, counting means this is 1, 2, 3, 4. But it has, like in natural numbers, we have infinite elements. So this is an infinite set, a set that has infinite number of elements. Is called infinite set. Like the, for example of the finite set is this 1, 2, 3, 4, right? And the example of this infinite set, the set of natural numbers. Set of this reals, set of rationals, etc. These are all infinite sets. Now we are coming some basic definition of the set. Some basic set or basic properties of the set, or we can say the same basic properties. Definitely these are the basic properties of a set or basic definition of a set. This is the classic definition of set. Now we are coming to the subset, superset. These are again the means we have finite set, infinite set is okay, but besides that we have this subset, superset, equality of sets, right? Proper set. So these are the properties of set, we can say, or we see this parts of sets, right? Classification of sets, we can say. So classification of set, the first property, first definition is that is of is subset. Right, now we are classifying sets, right? So first is this subset. So that is subset is if every element of a set I may write properly. Definition of a subset. So that is if every element of a set, if every element of a set if every element of a set A is an element of a, if every element of a set A is also an element of a set B, element of a set B and is also an element of a set B, then we say that A is a subset of B. Say, or then A is called the subset of B, right? So that means if every element of a set A is also an element of a set B, then A is called a subset of B. A may have the same, A or A and B may have the same number of elements, but it is, then we say the subset and equal to. It can be subset and equal to, but A is called, if every element of a set A is also an element of a set B, then besides that B has more elements, right? This can be possible that B may have more elements, but what is here? Let me define further. If every element of a set A is also an element of a set B, then A is called the subset of B. Means if we see the Venn diagram, we see the Venn diagram. This is our B and this is our A. So every element of this A is an element of B. Besides that, B has more elements. B has other elements that are not in A. And mathematically or numerically or symbolically is a symbol for the subset. Then this A is a subset of B. A is a subset of B. Is a subset of B. And the symbol for the subset is symbol for that is symbol for this is symbol for this is this, right? This means this is A is contained in B, and that is, and equality is here. A is either A is contained in B or A is equal to B. A can be equal to B or A cannot be equal to B. If we have this restriction, then we write the this is the symbol for containing and subset, right? A is a subset of B. That means A is a subset of B if A is contained in B. A is called a subset of B. A is contained in B. Right? For example, this A is having the elements is 1, 2, 3, 4, and B is having the elements this 1, 2, 3, 4, 5, 6, 7, 8. Then we say here that A is a subset of B, right? Since it is strictly contained in here, so we don't write this symbol. We just write A is, this is a proper subset, right? So we define the proper subset later, right? A is contained in B. This is just the definition of subset. A is also A is called a subset of B. A if A is contained in B, right? This is the symbol for the proper subset. Right? What is a proper subset? Here also again it is a proper subset. It's not equal to, right? So A is I didn't do, yeah, this is a symbol for the subset, but this is a proper subset, right? So A is a subset of, this is a proper, this is an example of a proper subset. This is an example of a proper subset. This may be, this can be, it can be like this. It can be like this. So it means this is A. It can be like this. right? The symbol for the subset is this. Proper for the proper subset is a symbol for this. Now the definition from the proper subset. This if every element of the set A is an element of the set B, and B contains at least one element B contains at least one element which does not belong to A. Does not belong to A. That means, we write A is contained in B and A is not equal to B. This is what is contained. Now equality of sets. Two sets are equal two sets A and B, we can say, because we are writing that A and B are equal if every element of A belongs to B and vice versa. Means, and every element of B belongs to A. Belongs to A. Right? So that is, we can write A equal to B. Equality of sets. Right? Or we write two sets are equal if every element of A belongs to B and every element of B belongs to A. Equivalent. Two sets A and B are equivalent if they have same number of elements. If their orders are equal. Now we have to define the order. If they have, so before defining equivalent, we must define order of a set. Order of a set is order of the set is the number of the elements in the set. In that set, right? And this is also known as cardinality. As cardinal. Like A is this 1, 2, 3, 4, then the order of A is this. In the form of cardinality, we can even write this. So order of A has two symbols, has two representation. One is this, the another one is this. So we can represent the order of A by writing OA or by writing A in between the two symbols of this. This is basically is the symbol for the cardinal, right? So order of A, we can write this is, or another form is in between the more, we can write A. So that is also order of A. This is also the order of A. Right. Now we are coming to the universal set. Universal set is basically all the sets a set that contains all the possible subsets no, it's better that all the subsets, right? Right, let me run a universal set, because universal set and the proper power of set coincides. The universal set is all the sets are assumed to be subset of a set, subset of a given fixed set. Fixed set, right? Like universe, we have the universe. In the universe, we have 9 planets. Now it becomes 8 planets. So all the sets are assumed to be subset of a fixed set, and which is known as universal set. Universal set. And this universal set is represented by U or X. Set is denoted by U and X. Right? Then we have power set. Right? The power set of A is denoted by PA, and it contains all subsets, or it has all, it contains all the subsets of A, all the possible subsets of A. Right. That means if A is this 1, 2, 3, right? This is one subset of itself. A is a subset of itself, right? Another is empty set, means the blank set. Let me write this empty set also before defining this this empty set. The set which has no element is known as empty set. Right? So I'll write here this empty set is the set which has no element. Set has no, a set without element. So a set without element is the empty set. This empty set is denoted by denoted by this or this without element. So you can see that this empty set is a subset of A. A itself is a subset of A, right? Another is 1 is a subset of A. 2 is a subset of A. 3 is a subset of A, right? And then we can see this 1, 2 is a subset of A. 1, 3 is a subset of A, right? Then we can see this 2, 3 is a subset of A, right? So we have all the possible, this 1, 2, 3, 1, 2, 1, 3, 2, 3, and then this empty and then A, right? So this power set of A is here we taking A as 1, 2, 3, right? So then the power set of A is this power set of A is, it is empty, it is 1, 2, 3, 1, 2, 1, 3, 2, 3, and A. That is 1, 2, 3. This is a power set of A, right? Now we have here we have 3 sets that has single element. These 3 sets are called singleton set. Set that has single element, that has one element only. Right? Is a singleton set. Right? Now we are coming to another. Union and intersection. Union and intersection. So I hope this union and intersection will discuss later. So I may close here, right? I must stop here. Okay. I must stop here. So thank you.